Hello, everybody. In today's lesson from Module 9 of the 6th grade Go Math textbook is Lesson 9.2, Prime Factorization. And we're on page 245 of the 6th grade Go Math book. So, finding factors of a number. Whole numbers that are multiplied to find a product are called factors of that product. You know, like 3 times 4 is 12. Well, 3 is a factor of 12, 4 is a factor of 12, so on. Okay, a number is divisible by its factors. For example, 4 and 2 are factors of 8 because 4 times 2 is 8, and 8 is divisible by 4 and by 2. All right, so let's look at example 1. Anna wants to build a rectangular garden with an area of 24 square feet. What are the possible whole number lengths and widths of the garden? Basically, is asking us what are the factors of 24. So we'll recall that area means length times width. And so for Anna's garden, 24 square feet equals the length times the width. So all we have to do is list the factors of 24 in pairs. And we're going to use each pair only once. Okay, so we're not going to say like 1 times 24 is, we're not going to use 24 times 1 as well. Okay, so it's kind of the same dimensions, right? Okay, it would just be turned a different direction. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, 5 won't work because it doesn't end in a 5 or a 0. 6 we already know works. 7, the closest we can get is 21 or 28. 8 we know already works. 9 will not work because the sum of 2 and 4 is not 9. So 9 can't be a factor. And it doesn't end in a 0, so it's not 10. Okay, so then we can use a diagram. Or you could use a diagram to show it. So 1 is connected to 24, 2 is connected to 12, 3 is connected to 8, and 4 is connected to 6. So we would say the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. So the possible lengths and widths are length of 24, a width of 1. A length of 12, a width of 2, a length of 8, and a width of 3, and a length of 6, and a width of 4. All right, so now let's try it ourselves. Let's list all the factors of each number. 21. Well, 21, isn't that 1 times 21? Okay, 2 will not work because that's not an even number. 3 will. 2 plus 1 is 3, so 3 will be a factor of 21. 3 times 7. 4 is not. It's not an even number. 5 will not work. It doesn't end in a 5 or 0. 6 will not work. I know 6 won't work because 2 is also not a factor of 21. Remember, 6, a number is divisible by 6 if 2 and 3 are factors. Okay, 7 we know is a factor. 8 is not a factor. 8, 16, 24 plus 8 is even. So there's no way to multiply by an even factor to get an odd product. 9 will not work. 2 plus 1 is 3. 3 is not divisible by 9. And 10 won't work. So that's it. Those are the only factors of 21. So 1, 3, 7, 21. All right, how about 37? Well, 37 I know is a prime number. Let's look at it. I know 1 times 37. Those are the only factors, right? Okay, so we can say 1 and 37. That's all you're going to get. 2 won't work because that's not an even number. 3 will not work because 7 plus 3 is 10. 10 is not divisible by 3. 4 will not work because this is an odd number. 5 will not work. Doesn't end in a 5 or 0. 6 will not work because 2 and 3 are not factors. 7 will not work. The closest I can get to 37 is 7 times 5, which is 35. 8 will not work because 8's an even factor, and this is an odd answer. 9 will not work because 7 plus 3 is 10, and 10 is not divisible by 9. So that's it. Those are the only two numbers. And you'll recall that that means that this is a prime number. All right, 42. Well, I know 1 times 42. 2 will work. 2 times 21. 3 will work. 4 plus 2 is 6. So that's 3 times 14. 4 will not work. 5 will not work. Doesn't end in 5 or 0. 6 will work. 6 times 7. 8 will not work. Even though this is an even number, the closest you can get is 40. 9 will not work because 4 plus 2 is 6. 6 is not divisible by 9. Okay, so we have 2, 4, 6, 8 factors of 42. So we can list them as 1, 2, 3, 6, 7, 14, 21, 42. Okay. And 30. Again, we know 1 and 30. 2 will work because it's an even number, so 2 and 15. 3 will work, 3 times 10. 4 will not work. The closest you can get is 4 times 7. 5 will work because it ends in a 0, 5 times 6. 7 will not work. 7's an odd. Well, 7 times nothing is 30. 7 times 4 is 28. That's the closest we're going to get. 8 times 4 is 32. That's the closest we can get. 9 will not work because 3 plus 0 is 3, and 3 is not divisible by 9. 10 we already have. All right, so we have 2, 4, 6, 8 factors of 30. So we have 1, 2, 3, 5, 6, 10, 15, 30. Okay. All right, let's go to page 246. All right, so activity 1, find the prime factorization of a number. So the prime factorization of a number is the number written as the product of the prime factors. Okay, so for example, the prime factors of 12 are 3, 2, and 2. 2 times 2 is 4. 4 times 3 is 12. Okay, so we want to get our numbers down to prime. Remember, 1 is neither prime nor composite, so 1 is not a number that we can use. All right, so there are several different ways to write the prime factorization of 12. We can show it as 2 times 3. We could say 2 with the symbol, the dot, times 2, symbol times 3. Or we can use what we learned about exponents and say, well, I have 2 sets of 2's, so 2 squared, or 2 raised to the second power, times 3. All right, so now A, let's list the factor pairs of 240. Well, that could take a while. Let's see. So 240. Well, what's the obvious one to start? 1 and 240. 2 will work. This is an even number. So 2 and 120. Will 3 work? Well, 2 plus 4 is 6, and 6 is divisible by 3. So 3 will work. 3 times 80. 4 will work. If you look at the last two digits, are they divisible by 4? 40 divided by 4, yes. So 4 will also work. And I know 4 times 6 tens is 24 tenths. 5 will work. It ends in a 0. And that'll be 5 times 48. Will 6 work? Yes, because 2 and 3 are also factors. So that's going to be 6 times 40. Will 7 work? Well, sometimes we just got to try. No, we're going to have a remainder. So no, 7 will not work. 8 will. I know that 8 times 3 tens is 240. 9. How about 9? Will 9 work? 4 plus 2 is 6. 6 is not divisible by 9, so 9 will not work. How about 10? Yeah, sure. It ends in a 0. So 10 times 24. 11? No, I don't believe so, right? But let's try. So we get 11 times 2 is 22. Subtract, we get 2. 20 divided by 11 is 1. So we're going to be left with a remainder of 9. So no, 11 will not work. 12 will. And 12 times 20 is 240. 13? I don't think so. But let's try. No, we're going to be left with a remainder of 6. So 13 won't work. How about 14? No, we're left with a remainder of 2. 17 won't. 14 won't work. 15. I think 15 will work. The reason I say that is because 5 and 3 are factors. And 5 and 3 are also factors of 15. So I think this should work. Yes, 16 times. Okay. Okay. And then we get back to 20. So, all right, so those are it. Okay, but there's a lot, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs. So let's go ahead and write them out. 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5 and 48, 6 and 40, 8 and 30, 10 and 24, 12 and 20, and 15 and 16. 15 times 16. All right. Now those are factor pairs. They're not prime factors. Okay, 3 is a prime factor, 2 is a prime factor, and 5 is a prime factor. The rest are not. So this would not be the prime factorization of 240. So we can choose any of these factor pairs. That was the whole point of this, basically, finding a starting point for 240 if we want to write the prime factorization. So we notice here that they started with 48. Okay, so they're going 48 times 5. Okay, so put 5 right there. Now 5 is prime, so just circle it. 48 is not prime. What could we use? Well, I know 3 is a factor of it because 8 and 4 is 12. So I know 3 times 16 is 48. All right. So 3 is prime. Only 1 and 3 are its factors. 16. I know 2 times 8 is 16. 2 is prime. 8's not prime because I know 2 is a factor of 8. So 2 is prime again. And 4 is not because 2 times 2 gives us 4. But 2 is prime. All right, so now we're at the prime. We have all prime numbers, right? Oh, I was not supposed to circle 8. That was my mistake. Sorry about that. We only want to circle the prime numbers. Okay. All right, so the prime factorization. I'm going to go start with the lower prime numbers. I have 2 times 2 times 2 times 2 times 3 times 5. All right, now write that using exponents. So how many 2's do we have? 1, 2, 3, 4. So we have 2 to the 4th times 1, 3 times 1, 5. So we have 2 to the 4th times 3 times 5. All right, what will the factor tree for 240 look like if you start the tree with a different factor tree, factor pair? I don't know, let's say we did 4 and 60. Well, these are prime factors, right? So I multiply those together, I get 240. So it shouldn't matter where I start from. The intermediate steps may be different, but the prime factors will be the same. So intermediate steps, in other words, are what are the different branches we're using to get there, the intermediate steps. Okay, so that would be my guess, that since these are the prime factors of 240, that if I start here with another factor pair, I'm still going to wind up with those 6 prime factors. So let's try it. What do we want to start with? You can start with anything. We can do 10 and 24. You could do 15 and 16. You could do 12 and 20, 8 and 30, so on, okay? Any factor pair you choose. All right, well, neither one of these are prime. 10 is made up of 2 times 5. Okay, those are both prime. And 24, well, that's made up of 3 times 8. 3 is prime. 8's not. 2 times 4. That 2 is prime. The 4 is not. Okay, so let's see. 1, 2, 3, 4 twos. 4 twos. 1, 3, 1, 3, 1, 5. So it's still the same. 2 to the 4th times 3 times 5. Okay. So my steps are different, but I still get the same prime factorization. All right. Another way we can do it, other than a factor tree, is a method called the ladder diagram. And so to use a ladder diagram to find the prime factorization of, say, 132, we're going to write 132 in the top step of the ladder. We're going to start by choosing a prime factor. Well, this is an even number, so the smallest, or the prime factor we know is 2. 2 has to be a factor of 132 because it's an even number. So you're going to choose the prime factor of 132 to write next to the step with 2. I'm sorry, next to the step with 132. Divide 132 by 2 and you get 66. So we're going to write 66 in the next step, and we're now going to divide 66 by a prime factor. Well, you could choose 2 again, right? 66 divided by 2. Well, that's going to be 33, right? All right, well, what's a prime factor of 33? Well, I know 3 will work because 3 plus 3 is 6, and 6 can be divided by 3. 33 divided by 3, that's 11. All right. And what is the prime factorization of 11? Or what is the prime factor of 11? 11. So 11 divided by 11 is 1. So it says keep choosing prime factors, dividing and adding to the ladder until you get to a quotient of 1. So I got to 1. Now, what are the prime factors of 132? How can you tell from the ladder diagram? Do you notice on the outside that those are the prime factors? Okay. So go ahead and write the prime factors of 132, which would be 2 times 2 times 3 times 11. Remember, 1 is not a prime factor. How do we know which ones are the prime numbers? They are written to the left of the steps. All right, write the prime factorization of 132 using exponents. Well, we have two 2's, so 2 squared, we have 1 3, and we have 1 11. So 2 squared times 3 times 11. So complete a factor tree and a ladder diagram to find the prime factorization of 54. All right, let's do a factor tree first. What's a factor pair of 54? Well, some of you might say 2 and 27. So you could start there. Others might say, oh, well, 5 plus 4, that's 9. Oh, well, 9 can be divided by 9, so 9 is a factor. Oh, yeah, that's just a basic math fact. 6 times 9. I think I'm going to start there. Okay. Somebody else might start with 3 and 18. It doesn't matter where you start. Okay, as long as when you multiply them together, you get 54. That's for a factor tree, right? We just need a factor pair. All right, 6, that is not prime. That's made up of 2 times 3. Okay, 2 is prime, 3 is prime. 9 is not prime, but it's made up of 3 times 3. Okay, so that's prime. So we have 2 times 3 times 3 times 3. Or 2 times 3 to the third. All right, how about using a ladder model? All right, what is a prime factor of 54? Well, we already said that we knew 2 has to be a factor because it's an even number. And 54 divided by 2 is 27. What's a prime factor of 27? 3. Because I know 3 times 9 is 27. I know 3 is a prime factor of 9, and 9 divided by 3 is 3. Well, a prime factor of 3 is 3, and 3 divided by 3 is 1. So what are the prime factors? We have 1, 2. We have 3 times 3 times 3. So 2 times 3 cubed. Okay, so we wind up with the same answer, right? All right, 7. If one person uses a ladder diagram and another uses a factor tree to write a prime factorization, will they get the same result? Yeah. There's only one prime factorization for a number. So there's only one prime factorization for every integer greater than 1. So it doesn't matter if you use a ladder diagram or a factor tree. All right, let's look at page 248. Number 1. Use a diagram to list the factor pairs of each number. So you remember that the diagram, that was where we underline it and we connect it with arrows. Okay, so I'm going to go ahead and write the factor pairs of 18 first. Okay, so that's 1 and 18, 2 and 9, 3 and 6, 4 is not, 5 is not, and 6 we're already getting back around. So we have 3 factor pairs. And so I'm going to say 1 and 18, 2 and 9, and 3 and 6. And now you're just going to join the factor pairs. Okay, so 1 and 18 go together. 2 and 9 go together. And 3 and 6 go together. All right, 52. Well, we know 1 times 52. We know 2 will work because it's an even number, so 2 and 26. 3 will not work. 5 plus 2 is 7, so that will not work. How about 4? 4 might work, so sometimes we just have to try it. Yes, 4 times 13 is 52. 5 will not work. It doesn't end in a 5 or a 0. 6 will not work because I know that 3 and 2 are not both factors of 52. 7, the closest I can get is 7 times 7, right? 49. 8, the closest I can get is 8 times 6, 48. 8 times 7 is 56, so the closest I can get is 4 away. 9, no, because 5 plus 2 is 7. 7 is not divisible by 9. 10 will not work because it doesn't end in 0. 11, no, because anything divisible by 11 will, both the numbers will be the same. The digits will be the same. 12, 12, 24, 36, 48, 60, nope. And we have 13. So now we're back around. So we have 1 and 52, 2 and 26, and 4 and 13. Join the outside ones, 1 and 52. Join the 2 and the 26, and finally the 4 and the 13. Okay. All right, let's look at number 3. Carl needs to build a stage that has an area of 72 square feet. The length of the stage should be longer than the width. Okay, so that's a clue for us, right? So what are the possible whole number measurements for the length and width? So we need two numbers multiplied together to give us 72, but the length has to be longer, right? Well, we know 1 and 72, right? We know 2 and 36. Will 3 work? Sure. 3 and 24 is 72. Will 4 work? Well, let's try it. 72 divided by 4. So 18. So that'll work. 18 and 4. 5 will not work because 72 does not end in a 5 or 0. 6 will work because the 2 and 3 are both factors of 72. So 6 will work, and it's 6 times 12. Now I know there's also the basic math fact of 9 times 8. So 9 and 8. Right, number 4. Use a factor tree to find the prime factorization of each number. All right, so they got started here. They said 402 divided by 201 times 2. All right, well, that's prime. 201 is not. 2 plus 1 is 3. So I'm going to go start with 3. Now, I don't know what 201 divided by 3 is. So I can just divide it. Okay, so it's 67. 3 times 67. 67. 2 doesn't work. 3 won't work because 6 plus 7 is 13. 4 won't work because that's an odd number. 5 won't work. It doesn't end in a 5 or 0. 6 would not work because 2 and 3 aren't factors. 7 won't work. 7 times 9 is 63. 8, no, because 67 is odd. 9, no, 6 and 7 is 13. 13 can't be divided by 9. 10. 67 is prime. Okay, so we're done with that one. It's 2 times 3 times 67. All right, 36. Okay, we have to use a prime factorization tree. I'm going to do 4 times 9. Some of you might want to use 6 times 6. Some might want to use 2 and 18. Okay, 3 and 12. All right, 4 is not prime. It's made up of 2 times 2. All right, 2s are prime. 9, that's made up of 3 times 3. All right, so I'm done with that. So we're going to have 2 squared times 3 squared. Okay, use a ladder diagram to find the prime factorization of each number in 32, or 32. So let's start with 32. Put it on the first step. I know a prime factor of 32 is 2 because 32 is even. I happen to know that 2 times 16 is 32. 16 is even, so I'm going to divide that by 2. 16 divided by 2 gives me 8. Again, 8's even, so I'm going to divide by 2 again. 8 divided by 2 is 4. 4 is even, so I'm going to divide by 2 again. All right. Remember, I have to keep going until I get a quotient of 1. So 2 divided by 2 gives me 1. All right, so 1, 2, 3, 4, 5. 2 to the 5th power. 27. I'm going to start with 3 and 9. 9 can be divided by 3. 3 can be divided by 3. So we have 3 to the 3rd power. All right, number 8. Tell how you know when you found the prime factorization of a number. Okay, so first, all the numbers have to be prime. Or all the factors are prime. And when you multiply them together, you get the original number. Okay. All right, so we're going to stop there. We'll consider that part 1. In part 2, I'll go over the independent practice problems, numbers 9 through 22. So until then, I'll see you soon.